Come to the question then. So let's say that let's start with the problem. Then while solving this, we can display the principle. Okay. So the problem is as follows. There are 5 people. Okay. Let's say person 1, person 2, person 3. Let's take 4 people, person 4. And there are 4 seats. Okay. So S1, S2, S3, S4. So the seats are fixed there. Okay. You can't move them. Imagine in a park, the seats are connected and they are fixed. Okay. Now the question is, as you can probably guess, how many ways, okay, can these 4 people, be seated? Let me give you an example, maybe so that the question becomes more clear. One example is, maybe as an example, we could have something like this. Person 1 seated in seat 1, person 2 seated in seat 2, and so on, right? This is one example. Another example could be the very opposite, right? It could be like this. So what we want to know is, what are the all possible ways to do this problem? Okay, yeah. So you can think ideas. Okay, so Raghav is he's saying 16. Okay, we'll take this. Raghav, do you want to give us an explanation as well?
There are 4 people and there are 4 seats. I think 4 into 4 will be the good.
But you need to give more explanation because okay, it seems okay 4 into 4, fine, but there is no reason, right? It is more of based on the most obvious thing to do.
Sir, each person, each seat. So in every pattern, the first person can sit in S1, S2, S3, S4. Then P2, person 2 can sit on S1, S2, S3, S4, and person 3 can also sit on S1, S2, and person 4 also S1, S2, S3, S4. So there will be 16 different ways.
But you see, Adityan, when on one seat, 2 people cannot sit, right? For example, this arrangement that I made here, this is one arrangement, right? But if the person 1 sits in seat 1, then in that case, so let's look at the case in which person 1 sits in seat 1. In this case also there are more possibilities. For example, person 2 can sit in seat 3, right? You see the problem that's happening, right? So when you're saying the case in which person 1 sits in seat 1 or seat 2, seat 3, seat 4, and so on, so you're taking 4, right? So yeah, person 1 sitting in seat 1, person 1 sitting in seat 2, person 1 sitting in seat 3. So in this way you're giving us 4 answers. But you see, even this first answer has more possibilities. In this one, person 2 may sit in seat 2, or person 2 may sit in seat 3.
Okay.
So even this case has more possibilities. So I liked your first step, okay, that you are first just deciding for person 1. But yeah, even each case has more cases. Okay. So let's see. So we will go with the. So Raghav, your answer is slightly less than what it should be. Okay, but never mind. Let's see. I will go with what Adityan has given in the first step, though the later steps are not correct. But the first step I like, makes sense. So what I'll do, I'll just separate it into, I'll put some spaces. Okay. So number 1 situation is person 1 sitting in seat 1. And the second situation is person 1 sitting in seat 2, and so on. Just doing a little slowly. I can just tell you the formula as well, but just doing a little slowly to understand the thing. So when person 1 sits in seat 1, then you can go to the second step of the problem. That is, you can ask where person 2 will sit. Okay, so we can forget about the other cases, okay, for the time being. Now,
Okay.
in this problem only, we can just focus on where person 1 will, where person 2 will sit. So you see here, person 2 has how many choices? So now if you worry about person 2 in the second step, okay, then how many choices does he have? He can either sit in seat 2, he can either sit in seat 3, he can either sit in, or he can sit in seat 4.
Three different seats.
Three different choices, right? Right. Okay, I hope everybody is following this. Now, when the person 1 sits in seat 2, that's a completely different case, right? How many choices will person 2
Like,
have in this?
so if person two sits in seat two, then person two and three and four can have different seats also.
Sorry, no. So if person 1 sits in seat 2, then person 2 cannot sit in seat 2. So now we are in this case.
Yes, person two has to sit in seat one, seat three, seat four.
Right. So, but yeah, so even though there are different possibilities, the number is still 3.
Yes.
This is important. Okay, I hope everybody is seeing this. Yeah. So let's move forward then.
So the
So
number will always.
exactly. That is what is important for us. Yeah. So we don't, this means that eventually we'll just rely on the fact that the number is always same for all the cases, all the sub cases, and we don't have to write out everything. Of course, for the first time we can write, but later on we don't have to. Okay. But I'll just say that this will also lead to 3 cases, and I'll just stop. I will not write the exact cases. Okay. This will also lead to 3 cases. Let's see.
Yes.
Now, see, this is the reason why multiplication was invented. Okay, because when you have the first time you have 4, right? But then this first case is leading to 3 cases. Remember, the problem is not yet done. Person 3 and 4 are left. I'm just doing the explanation, whatever we have till now. Or we can just say that there were only 2 people. Let's say that there were only, so I'm just changing the problem, everybody, okay? Let's say that there were only 2 people. Is that all right? Fine?
Okay.
Yeah, and there are 4 seats. No problem. 2 seats will be empty. Let's say there are only 2 people. So now if you have 4 choices in the first step, each of them is leading to 3. So 3 choices plus 3 choices plus 3 choices plus 3 choices. Okay. So this thing happens a lot of time in mathematics, right? The same number comes again and again. Again, like number of hours you studied today, number of hours you studied tomorrow would almost be same every day. So it's just 30 into that. We just do 30 into that instead of adding it. Okay, so mathematicians have invented a symbol for this, and they have called this 3 times 4. Okay, 3 is the thing that we are using everywhere, and 4 is the number of times that it is coming. And the symbol for that is 3 times 4. Now, of course, we all know what 3 times 4 means, but I'm trying to show you the combinatorial side of what 3 times 4 means. See, 3 times 4 doesn't make the addition any simple. Okay, adding 3 so many times is as hard as multiplying 3 with 4, or adding 300 times is as hard as multiplying 3 with 100. Okay, it may not seem as hard because we have practiced multiplication a lot. So it may seem
Yeah.
that it's the same thing. What is he saying? But in fact, writing a number as a product doesn't make the number simple. It's just that we are more used to it. Okay, but yes, we do get a better sense of a lot of things like factors of it and so on. So the answer would be 3 into 4. Okay, so 12 is the answer. Okay, but this is, I've changed the question. Okay, so 16 can still be the answer for the final answer. I'm not saying no, but for this case, the answer is 12. So this is with the explanation. But let's pull out the key part in this question. Okay, the key is that in the first step there were 4 choices, because we'll have to abstract out the principle from this problem so that we can apply it in different situations also. And the first step there were 4 choices. Okay, and in the second step, for each of those 4 choices, this is important, so pay attention. For each of those 4 choices, there were 3 choices. Okay, that's why we are doing 4 into 3, 4 times 3. Okay, that's important. let's contrast it with a different situation where we don't multiply, we add. Though it will be obvious that we add, but I still just for the contrast purpose show it. Let's say, so I kind of asked this question. Let's say that I'm inside inside the house. And let's say that here I have 3 exits. And let's say on the right hand side, I have 4 exits. Okay. How many ways can I escape the house? Of course, from here I have 3 choices, and from here I have 4 choices. Right? Everybody is getting this? So it will be 4 plus 3 in this case. Now, obviously, it is 4 plus 3. If you think logically, without any maths, it's just 4 plus 3. Right? There are 4 choices on the left side, 3 choices on the right side. There is no two-step. There is no two-step going on here. Right? It is just in one step that is happening. That's why we are adding. Every choice you make, so a choice you make on this side, once you make the choice, doom, problem is over. There is no other next step. That's why it's just 4 plus 3. But it's clearly 4 plus 3. We all understand it. Okay, but in this case, it's different, right? First step, you have 4 choices. And for each of those 4 choices, we have 3 choices. Okay. So yeah, I mean, this explanation and reasoning, you do not have to give every time. Okay. Once I will show you this principle, then we can apply this to solve a lot of problems very fast. Okay. So this principle has a name, right? Anyone can guess what this principle is called? Name of this principle. Okay, this is called the multiplication principle. Okay, multiplication principle. So I will not do further much explanation because we should solve problems more and get the habit of it. So yeah, can anybody try to finish the problem from here if there were 4 people? So let's go back to the question. What if there were 4 people?
So if there were 4 people over here, the answer would be
The answer would be
24.
24. Ah, that is right. So Raghav has got the point, and he's also good at fast at calculations. Right, now the answer is 24. Adityan or Karthik, please try to explain to us why is 24 the right answer. Right. So you see, it is simple, right? Because from here again, so there are 12 cases right here. We understand